and you have the iteration formula is xi plus 1 is g of xi. Okay, generally you have an equation, you have a function, this becomes an equation when it's equal to 0. So this equation we will convert like this, like x equal to g of x form. Now provided this g of x, this guy, so this g of x guy, he is our iteration function. And the important point to note down here is, so this iteration function, so this is not unique. Okay, so this is not unique. So based on the form of an iteration function, we can decide whether or not this method converges. A very important point. You may get this point as a questionnaire, and let me make one clear point for you. That is, the just note down this one. The fixed point method or the fixed point, I can say iteration method, converges. Okay, converges if in the neighborhood, but unfortunately this point is not given in your Steven Chopra. Okay, if in the neighborhood, if in the neighborhood of the fixed point, the derivative of g of x, derivative of g of x has an absolute value. This is important here, absolute value is important. Has an absolute value that is smaller than 1. Has an absolute value that is, this is the hint for you. Okay, so with this you can decide whether, because you're saying that this g of x is not unique, it has various forms, we will do with the problem, so it is not unique. Okay, so but which g of x you have to choose then out of various forms of g of x for a single equation, which g of x you have to choose such that fixed point iteration method converges. Okay, and that point is this. So the what I want to say, the absolute value of the first derivative of iteration function, if this is less than 1 near the fixed point. Okay, if it is less than 1 near the fixed point, then fixed point method with this g of x will converge. I hope you're able to understand this. Okay, are you able to understand this? See, in the neighborhood of the fixed point, if you find the first derivative of that iteration function whose absolute value is less than 1, then fixed point method with that iteration function converges. Did you understand this?
Yes, sir.
Yeah, and this is called as, and I mean, you can treat this condition like this. You can treat this condition Lipse continuous. Okay, so Lipse continuous condition is this. So this is the condition. Okay, so Lipse continuous condition is this. So with this condition, definitely we can make things fine. Okay, for example, say, for example, I have a question like this: f of x is equal to e to the power of minus x minus x. and initial guess given to you x sub 0 say equal to 0. Okay, now we are going to find what the root value. We are going to find the root value, for this particular function. Okay, so this is f of x. Okay, so now you convert this to f of x equal to 0. So you have e power minus x equal to 0. Now you convert this to what here? X equal to g of x form, right? So you have x is equal to g of x, where g of x equal to what now? E to the power of minus x. Agree? So x equal to e power minus x, where g of x is equal to now e to the power of minus x. So how do we use this iteration formula here? So iteration formula says that you have xi plus 1. This guy is g of xi. Okay. So therefore, what I will do now? So first of all, I will take xi equal to 0. Okay. Now we do this. So you convert this to xi plus 1 and you convert this to g of xi. Now you can do. Now what you do, just take, for example, initial guess x not equal to 0. So I'll put it here. So okay, I'll put it here. So what is my g of 0 here? So my g of 0
Once.
is equal to e power minus 2, that's equal to 1. So therefore, when I put, so I got x1 equal to 1. When I put I equal to 0 here, like this, so g of x0, so g of x0 equal to 0, so g of 0 equal to 1, so x1 equal to 1. Similarly, find x2. So what is x2 here? x2 is equal to what? G of x1, right? So now what is x1? So this is 1. This is nothing but e power minus 1. What is e power minus 1 here? So what is e power minus 1? It is some 0.3679, right? Yes or not?
Yes, sir. 0.36.
Yeah, now x3 is, see, it's very simple. There's no big deal. Just find these things, it's enough. So now you have to find this 0. G of 0.3679. So you will get something like 0.6922. See, what you understand, see, from 1 you came to this. But what is the answer for this here? Already we found this one, right? The true solution for this particular equation is 0.567, some 14329, so on, right? So this is what your xt is. See, we started from 0. We started from initial guess 0. Okay, this one 0. Then we came to 1, and from 1 you came to 0.3679. But see, in the second iteration you came to 0.3679, but you're expecting 0.56714. So you would think that you are nowhere going to the answer, yes or not? But still, hold a minute, just go on, okay? Just continue your traveling. So in x3 you found 0.6922. You're again going beyond. So 0.567 is in between what? 0.3679 and 0.6922. Now we'll find x4. We'll see. So g of x3, okay? So therefore what you get now? G of 0.6922. Anyone? Anyone? Did you get like this? 0.5005?
Yes, sir. 0.5005.
Yeah, see, now you're moving to 0.5 zone, you see. Now you take g of x4. Okay, if you take x4, again you will go beyond. You'll get 0.6062. This is a peculiar function you have like this. You take x6, so you get g of x5. So this time again you will come down to 54, something like 54. Okay, so on you do. You do so on, you get something like 0.5796. You keep on do like this. So 0. You get 5601. So again, you will get something like 0.57, say 11, and so on. You get now 56 something 49. Okay. So now this 5649 is somewhat close to this. And similarly, you can keep on do. You can keep on do. You will get some answer somewhere here. So you have some linear convergence for this. Okay, like Newton-Raphson method and secant method. See, with the Newton-Raphson method and secant method, if I take Newton-Raphson method and secant method, what did you enjoy there? For the same question, we enjoyed what here? Quadratic convergence, right? It converged very fast, yes or not?
Yes,
But
sir.
in this case, see what's happening. We are going through several iterations, but still, of course, we are reaching towards the answer, and we are again going away from the answer, again reaching towards the answer, and going away and coming back, something whatever it's something. So when you go for fixed point method, the convergence rate is not that fast. It is somewhat slow. So you have linear convergence. So how do you come to know whether it is linear convergence or not? In sir. So just take epsilon A. I take my epsilon A in percentage is equal to what here? Like x new minus like x old, or present minus previous by present, all right, multiplied by 100. Okay, you can take anything. For example, this is my, okay, this is my initial value. Okay, I'll take from here, say 1 minus 0 by 1. Okay, so 1 minus 0 by 1 is 100 percentage. Then again, what do? I do this one, right? 0.3679 minus 1 by 0.3679. Yes or not? So I'll compare like second, what do I do? Again, I'll take 0.6922 minus 0.3679 by 0.6922. So on you do for every iteration, okay? And then you will observe that you have some kind of linear convergence. That means you may not reach solution very fast. You have to go through some more, some more number of iterations to get answer, okay? So are you able to understand these things? So fixed point method is very simple, right? Just substitute and then go. That's it. Yeah, you have a single initial guess for this. Now we will try to justify this particular statement. The fixed point iteration method converges if in the neighborhood of the fixed point, the first derivative of iteration function has an absolute value that is smaller than 1. So the absolute value of the slope, whatever you find near fixed point, must be always less than 1. Then you can choose that g of x, so that fixed point iteration method with that g of x will converge. Okay, so that's the motto. So now what we do, we to support or to validate that particular statement, whatever you have, so we will solve a simple question. Okay, for example, you have a question like this: x e to the power of 0.5x plus 1.2x minus 5 is equal to 0. Okay, so if you go to MATLAB, you can plot it. Okay, easy plot. You just go to MATLAB. Okay, easy plot, and put this expression in single quote. Not, you just take only from here to here in single quote, not skip that equal to 0 portion. Put it in single quote. So it will so easy plot is accepting input as a string. It will plot, okay, the curve, whatever it is. So if you observe the curve, you will get root. Okay, the root is in between 1 and 2. For x equal to 1, root is in between x equal to 1 and 2. Okay, so anyways, my intention is what here? I want to use fixed point iteration method to find the root of this equation. I want to use this. So to use this, I have iteration. So that is xi plus 1 equal to z of xi. Okay. Now what is my goal? My goal is I have to construct whatever equation I have. You have to, modify like this. So I will take case 1. Okay. So let me take, okay, let me take, which color I can take now? More colors. Which color is decent here? All are looking dark. There is no light color. Let me take this color. Uh, okay. So I'll take, I think already we have this color. So let me take case 1. Okay. So can you tell me one way? Okay. Case 1, let me write down like this. X is equal to 5 minus x e power 0.5x divided by 1.2. Okay, see, this one we have done like this. The entire stuff we have done this. We agree? One of the ways showing that f of x equal to 0 as x equal to g of x form. Yes or not?
Yes, sir.
Yeah, one of the ways is this. So therefore, my g of x is what here? So this guy is my g of x. So he is Mr. g of x, iteration function. Okay, now according to Lipschitz continuous condition, what is my condition here? Now whatever g of x you're choosing now, you're choosing, so you find its first derivative and then absolute value that must be less than 1. Okay, near what? Near the fixed point. So that is important. Okay, so now this is my g of x. I would like to find its first derivative. So g prime x. So can you find out this for me? So I think you must get minus e power 0.5x. Okay, I'll take minus common. So plus 0.5x e power 0.5x divided by 1.2. Yes or not? Just derivative.
Yes, sir.
Now you tell me for what values I have to check this condition here. I must take, see, I must find the derivative of g of x where? Near the neighborhood of the fixed point. Yes or not? Near the neighborhood of the fixed point. Because see, how do I come to know? So because if you plot the curve, you'll come to know. See, in the examination, you will not plot the curve. So they will give you the neighborhood points also in the examination. Don't worry. Okay. So in this question, what are the neighborhood points here? As the root is in between 1 and 2. Yeah. So these are my neighborhood points. So therefore, what do I do now? So I will find g of x at x equal to 1. Okay, so you please put this. So you get minus 0.5, so multiplied by 1. So for the first time I will do like this. Second time onwards I can directly get the values. 0.5 multiplied by 1 by C. In the examination, what we will do, in overlook, you will forget this brackets here. You know the method, everything is perfect, but you forget this brackets. You know what you will do? You will take like this, minus e power 0.5x plus 0.5x into e power 0.5x, gone. Yeah, gone, right? So please mind these things. I'm telling you because in CM, in overlook. Whenever you're taking temps as common, always mind those signs, whether it is negative or positive. Okay, because however you do, whatever you do, once you deviate from the solution, means it's out. Because sometimes what happens, you're about to diverge, but because of that silly mistake you may converge. Okay, so that will really, they will give you 0 marks for that. So please, you don't fall under that particular zone. So I'm telling you again and again. So because I know many of you. So any answer for this?
Sir,
Minus 2 point.
minus 0.6.
Yes or not?
Yes, sir.
Very good. Someone supported me. Thank you very much. But whoever supported me or whoever respond me, because things are recorded, right? I will, with patience, I will see everything here. Whoever is supporting me, I will give random high marks. I will give plus 20, plus 10, plus 30, whatever I want, I will give. Okay. Now, other neighborhood point we have. See, neighborhood points means what? See, the function, if you find the solution of the function between any two values, okay, those two values become neighborhood. So in the examination, they will definitely give these neighborhood points. Okay. So G prime 2 is equal to, again, same stuff you do. So what do you get now? You must get minus 4.5305. Okay. Just you put in place of 1, you put 2, what is there, okay? See, now in place of 1, you put 2. Here also 2. Okay, so you will get minus 4.5305. Now what do you do? Are these two less than 1? Is G prime 1 and G prime 2 less than 1?
Yes, sir.
No, of course they are less than
Absolute
1.
values.
Yeah,
Right.
but we have to take absolute value, okay? Please don't think like me, think like you smart. So a mundane candidate like me, uh, I mean, may omit this absoluteness. If I take this absoluteness, then gone. So minus 2.0609, and this is unfortunate. So I'll get a positive 2.0609. This is unfortunate. So this is greater than 1, gone. Okay, and again I'll find the absolute value for G prime 2. Okay, and that means I'll get now positive 4.5305. This value is also greater than 1. What more you can do? You will have to, okay, wait for some time. So what you do now, that means this elliptic continuous condition is not met with. Okay, so this is because I have to take absolute value here. This condition is not met with. So therefore, what to do here? Therefore, now I can say you that if at all I choose g of x like this, if I choose this fellow as my g of x, I will always diverge. Yes or not? Yes or not?
Yes, sir.
So
Yes.
in the examination you have tried like this. So therefore, if g of x is equal to 5 minus x e power 0.5x by 1.2, now what happens? This method diverges. Method diverges means not this method. With this method, you will find the divergence solution. Okay, that's the meaning. Okay, so therefore I can't take this. Okay, and we will prove, because this condition also we can prove by solving a problem, and we will prove that if I take this g of x, how I will go out of the solution, that will prove. All right, so we will do step by step, don't worry. And then if I'll take case 2, let me use some other color for case 2. So let me take case 2. My case 2 I will take like this: x equal to g of x form. So I'll take x is equal to 5 by e power 0.5x. So in the exponent I have 0.5x, okay, plus Mr. 1.2. I have this. You see, your function is this one, right? Your function is this. So what I took now? I took x common here, okay? I took x common here, and I wrote x is equal to 5 by remaining. Yes or not? Yeah? So I took x common
Yes.
from these two. Okay, and I write, and we obtain like this now: x equal to g of x, 5 by e power 0.5x plus 1.2. Do you agree with this? Agree?
Yes, sir.
Yeah, great. So now Mr. G of X is this. See, my G of X is not unique, okay? In the former case, in the case one, my G of X is appeared to be something like this. Now in case two, this guy changed to this way. So he's not unique. That's the meaning. However you go, if G of X is not changing its form, you could say that particular iteration function is perfectly unique. Okay, otherwise it's not unique. Okay, now it's not unique, it's changing its form like chameli. Okay, anyways, so x equal to 5 by e power 0.5x plus 1.2. Now what do I do? In no time I'll go for this. So I want to find my first derivative of g of x. Okay, so now what you get? Okay, this I can do. So you get minus 5 e power 0.5x by twice e power 0.5x plus 1.2 whole square. Yes or not? Yes or
Yes, sir.
not?
Yes, sir.
So now what you do? Now I have this neighborhood. Within the neighborhood region, I wish to find my solution. So I take g prime 1. So minus 5 e power 0.5. I'll do for the first one. And remaining we can plug in like that. E power 0.5 multiplied by 1 plus 1.2 whole square. I just plugged in, nothing else I did. I just plugged in x by 1. So if you do this, you must get what? Minus 0.5079. Just confirm this.
Yes, sir.
Yeah. Similarly, you do g prime 2. So derivative of g of x for x equal to 2. Now directly we can write, okay? So derivative of g of x at x equal to 2 is what, man? Minus 0. So now we are blissful, okay? So g prime 2 is this and g prime 1 is this. All right? So are you going to get a convergence here?
Yes, sir, converging.
Happily, right? So if I find my, I'll try to find my g prime 1 magnitude. So now this time I get positive 0.5079. This guy is happy less than 1. I'm waiting for this moment. Okay? Now blissful, I'm happy. Hooray. Okay, and again I find my g prime 2, I find its magnitude. So Mr. G prime 2, you find this guy's magnitude. He is again positive 4426. This total fellow, this total quantity is also less than 1. I'm very happy now. Okay, now I'm very happy. I'm laughing. Yeah, I'm stop for extra. Okay, so now at end of the day, this guy is converging within the neighborhood, okay, or in the vicinity of the neighborhood of g of x. So definitely I could say this g of x is going to converge. I mean, if I use this g of x for the fixed point iteration method, I'm going to definitely converge. Other way of writing, let's find if there is any other form of g of x with which we can get some convergence, okay? So therefore, case, can I write like this? X is equal to 5 minus 1.2x by e power 0.5x. Yeah? Can I write like this? You just hit this function. Okay? Yeah? Now, see, you take this guy this side, okay? then you find for this x. Yes or no? Other way. So you get 5 minus 1.2x by e power 0.5x, right? Yeah. Now who is your g of x again? On the right hand side, Mr. g of x is sitting. Yeah. He is sitting on the right hand side. Now g of x is that. I would like to find its first derivative. So what we get now? So we get minus 3.7 plus 0.6x by, so you must get e power 0.5x. Agree? Agree? Or just to do what is there? Yes or not?
Yes, sir.
Yeah. Now I have the points g prime 1. So I'll do for the first. So 0.6 multiplied by 1, I have 1. Okay, by e power 0.5 multiplied by 1. So what are we going to get?
Minus 1.88. Sir.
8802. Great. That's fine. So G prime 2 on similar grounds. So G prime 2 is minus 0 point, you get something like 9197. Yes or not? Yeah? Now, what is unfortunate here? Any unfortunate situation you have here? G prime 1 whose magnitude is equal to, you get positive 1.8802. Is it less than 1 or greater than 1? Greater than 1. So gone. Okay, I'll take absolute value for G prime 2 and I got here positive 0.9197. Is it greater than 1 or less than 1? Less than 1. Okay. So now what do you do? So you're happy here. But end of the day, what? End of the day, what's the problem? I am neither happy nor unhappy. Okay. So I got stuck. I can't take up this particular problem. I can't take up this particular iteration function because one of the roots, the derivatives at one of the roots, I mean at one of the domain values, that is x equal to 2, is satisfied, but for the other thing x equal to 1, it's not satisfied. So which one do you think is good now? Case 1 or case 2 or case 3?
Case
So
2, sir.
yeah, so this fellow finally he qualified. This fellow qualified the race. Now, if you use this guy as your iteration function, definitely you will get the convergence. I mean the convergence answer. Elsewhere, you will go beyond. Okay, so we will try to, I mean, what you call. So I will try to take case 1. Where is my case 1? Okay, case 1 is that. So so we decided that, so case 2 g of x is a good one, okay? So I will take that. So what is my case 2? So I will choose Mr. Case 2. He qualified the race. So I have x is equal to, what is my case 2 here? X is equal to
5 by
5,
e
right?
power 0.5x.
Okay, 0.5x plus
1
1.2, right? Right, good. Plus 1.2. I want to make this one as what? Xi plus 1 is equal to this one, okay? So we have constructed this way. So xi plus 1 is equal to g of xi. Okay, now what we do, so we came to know that the root is in between, where and where, x equal to 1 and 2. So therefore I'll start with my 1. Okay, so I'll start with my 1. So if I take x equal to 1, so if you take x equal to 1, then what is xi plus 1? I take x equal to 1, okay? So let me take, for x equal to 1, Now I take x1 is equal to 5 by e power 0.5 times 1 plus 1.2, right? ఎంత ఇది సాల్వ్ చేయడం వస్తుంది ఇది 1.7.
1.75, sir.
Okay, now similarly find x2. Similarly find for the second one.
1.276.
1 point. So what you do here, instead of this one,
276.
I'll take what your e power 0.5 multiplied by this one, right? So put this 1.7552 plus 1.2. This is very simple. It's a matter of only substitution. You get 1.38.
386.
Okay, so great. Similarly, you find like x3. So x3 is equal to now 5 divided by, so e power 0.5. So instead of this, now you take this one. So 1.3869 plus, so plus 1.2. Okay, so what do you get now?
1.5.
Yeah, correct. 1.5622. Similarly, so on you find, okay? So on you find your answer, your true solution for this is like this. Your true solution for this one is what you know. It's something like 1.5050. Okay, your true solution is something this. So you started somewhere and you see how you're coming. You see I started with 1, x equal to 1. I went to 1.755, more than this, and again I came less than 1.5. I came to 1.3. Again I'm going to close to 1.5050. I got 1.5622. I didn't get my answer yet, so x4 is equal to, I'll go further. So you get 5 by, you can just do, okay, just substitute. So 1.5622 plus 1.2, and then you will get what? You will get around some 1.4776. See, will this happen with Newton-Raphson method or with secant method here? With secant method or Newton-Raphson method, if you choose the initial guess very close to the true solution, then you will definitely converge very fast, right? Of course, based on the nature of the function also, you will converge very fast, quadratic convergence. But see here, what's happening here is, see, this swinging is there with fixed point method. I started with 1 and I went to 1.7, but I want something 1.5050. Again, other iteration I got 1.38. Yeah, again I came below to 1.5. Again I go beyond 1.5. I got 1.56. Now again I came less than 1.5, 1.4776. So now what you do without losing heart, you go to x5. Okay. So x5 is equal to what here? If you do, you will get something like 1.5182. So on, if you go for x6, you will get something like 1.4986. So can you confirm this now? So this is somewhat okay, right? Yes or not? This is somewhat okay when compared to remaining iterations. So 5050, I have 4986. So I can approximate. See, numerical solutions cannot be always exact. See, analytical solutions are exact, numerical solutions are always approximate, yes or not? So I have here 1.4986. Yeah, okay.
Yes, sir.
You can take, see, you have substituted x equal to 1, right, initially. Now you take x equal to 2. Again, you go home and put x equal to 2, and again you check it. Again, you will see convergence, okay? Now I'll take case 1. So what is my case 1 here? So if I go for case 1, again I will have to construct xa plus 1 equal to g of xa form. So therefore my g of x is what here?
5 minus x
Yeah, 5 minus x.
e power 0.5x.
5 minus x e power 0.5x by 1.2, right?
1.2, sir.
By 1.2. Now what you do, again you start with, by taking x equal to 1, or you can take x equal to 2, whatever you want you can take, okay? I have two options. Either I can take x equal to 1 or x equal to 2, because your root is in between x equal to 1 and 2. So please don't confuse, okay? So I'll find my x1 is equal to 5 minus, you plug in x equal to 1 here. So 1 e power 0.5 times 1 by 1.2. So any answer, please? You must get like this. Did you get so?
Yes, sir.
Yeah, gone. See, bang. Now you are really going, okay, but we have to confirm. Let's confirm after some 2 to 3 iterations, okay? Directly we first, in the very first run, please don't confirm. So I just plug in this 2.7927. Okay, let me plug in this divided by 1.2. So what you get now? You get minus 5.2364. From this one you can confirm, right? You are going very far now. See, where is 1.5050 and where are we going? You find for x3. So now you plug in this quantity. So minus 5.2364, okay, multiplied by e power 0.5 multiplied by, you please carefully observe the signs, whether that's a positive number or negative number. I'm telling again and again because your seniors did these mistakes in overlook. It's a matter of overlook, okay? So you do this, you will get something 4.4849. Similarly, you plug in this fellow and x4, you will get something crazy. And I find x4. Okay, you will get something like minus 31.0262. Do you wish to move further here? Do you wish to move further by seeing this big number? Do you wish to move further? No, right? You can't move because every time you will find epsilon a every time, and you would see that this will go double, triple, quadruple. It's more than that. So therefore, you are diverging, right?
Yes, sir.
You're diverging. That's it. You must get some 1.5050 as some answer. Your answer must be close to 1.5050. This one. But now you're getting somewhere some minus 31.02, something like this. This clearly indicates that you're diverging. So please go home and check with case 3. Okay. So among these cases 1, 2, 3, so case 2 is succeeded, whereas case 1 and 3 are out of race. Yeah. Are you able to understand these things here? Did you get the feel?
Yes, sir.
Yeah, that's it. So when should the iterations be stopped? Again, you know very well, okay? So if some stopped criteria is given, until epsilon a is less than or equal to epsilon s, we have to keep on iterate, or f of x equal to 0. Same. The stopping criteria is same for almost all the methods, okay? So this is all about our unit number 1. Do you have any questions to ask? So if
No,
you
sir,
have
nothing.
any questions, please ask me. Any questions, please? At least, did you understand this topic?
Yes, sir. Yes, sir.
Yeah.
Understood.
So now we'll close here. Now time is 5:50 sharp. I don't want to take an extra time, but at this juncture, you have to keep some points in mind. See, among open methods, Newton-Raphson method, secant method, and modified secant method, these three they behave quadratic convergence. So quadratic convergence is inheritance with these three methods. Whereas when you go to fixed point method, you may get some zigzag curve. Yeah. And also you have something called linear convergence with secant, with fixed point method. So fixed point method is, may not be handy always, but among all the methods, among all open methods, Newton-Raphson method is the most favorite, but sometimes secant method will also outperform Newton method, and sometimes secant method will take the lion's share, okay? So you can swing in between secant method and Newton-Raphson method. For some functions, Newton is good. For some other functions, secant is good, okay? But there will be race, strictly speaking, only between these two. Fixed point method is very far from these two always, okay? So shall we close now? Or do you have any questions?
Yes, sir.
We can close. Thank you. So this is the end of unit number 1. Okay, we will start unit number 2 in the next class. Thank you.